Welcome back to the Algebra Academy, and for today's video, the main question is the same as last time: how to solve for the x-intercepts when given a quadratic equation. And in the last video, we covered that there are three main ways to do this: factoring, using the quadratic formula, and completing the square. In the last video, we covered factoring. This time we will be using the quadratic formula to find x-intercepts. So in order to learn how to use the quadratic formula, we will be using this equation: y equals 6x squared minus 17x plus 12. So the first step in learning how to use the quadratic equation is learning the parts of a quadratic equation when in standard form. And this is what it is. So when written in standard form, a quadratic equation is written as y equals ax squared plus bx plus c. And you need to know what the parts of the equation are so you can identify them and use them when you are using the quadratic formula to solve for x-intercepts. So these are the parts of the standard form equation. A, b, and c are all constants, and they're very important to know for using the quadratic formula, and x and y are the unknown variables. So here is the actual quadratic formula itself. It is x equals negative b, which can also be said as opposite of b, because if b is a negative number, then this first part right here of the equation should be positive. So for example, if b is negative 6, this part should be 6. So x equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. Going back to our equation. So now that we know what the parts of the standard form equation are, we can identify what a is, what b is, and what c is, and use those values to plug into the quadratic formula. So looking at our equation, we can see that a equals 6, b equals negative 17, and c equals 12. And you have to always, when finding the a, b, and c values, include the sign that comes directly in front of it. So if our equation was negative 6x squared, then our a value would be negative 6. And as you can see, our b value is negative 17 because it's minus 17x, not plus 17x. And the same applies for c. If it was minus 12, our c value would be negative 12. But it's plus 12, so our c value is positive 12. So now we have our a, b, and c values, all we need to do is plug them into the quadratic formula. Once we plug in all our values, this is our new equation. And it does look rather intimidating right now, but that's just because we haven't simplified it yet. So we just need to simplify all of these parts. So negative 17 to the second power is positive 289. Then 4 times 6 times 12 is positive 288. And 2 times 6 is 12. Making this our new equation, which looks a lot more simple. Then we simplify it even further, because 289 minus 288 is 1. Now we have 17 plus and minus square root of 1, and square root of 1 is just 1. Now we split this one equation into two equations, because as you can see, we're not just adding 1 to 17 and we're not just subtracting 1 from 17. We're doing both because we have two x-intercepts in this specific quadratic equation. So we have to solve for x when 17 plus 1 over 12, and we have to solve for x for 17 minus 1 over 12. And when we simplify that, both of them, we get 18 over 12 and 16 over 12. And when we simplify those even further, then we get 3 over 2 and 4 over 3. Meaning that we have two real x-intercepts for this specific quadratic equation. One of them is 3 over 2, and one of them is 4 over 3. And these are our x-intercepts. 3 over 2, 0, 4 over 3, 0, which is 1.5, 0, and roughly 1.33, 0. And we can see this in our graph when we graph it right here.